Okay, so in this video we're going to take a minute to go over the kinds of views that you may need to submit with your design patent or your utility patent application. I'm going to try to make this quick. There's going to be some technical material into it, so I don't want to bore you guys. I know you have better things to do. So let's get started with that. First, we're going to take a look at the language. Now these are the angles, and we'll get to that. But let's make sure that we have an apples-to-apples comparison between the design patent language and the utility patent language. This is officially from USPTO.gov, so these are the standards. All right. I just want to point out that the language between design and utility for the views and drawing standards are the same. I just want to clear that up right now. That people are often confused by this. All right, the difference is when you're looking at it online is that the formatting on the utility side is way better. I mean, look at this. Much easier to understand, right? But just to shore that up, we're going to do a text comparison. So I have this up right here. Simple online text compare app, right? No big deal. Let's get started on this side. So we have the views. Copy this, paste it in here. Copy the views on the utility side. Paste that back in here. Compare. Okay, so it looks like detail on the left and detailed on the right, not a big deal. And they have center lines here, one word, and center lines on the utility side is 2 words, but virtually the same. Let's clear that. Let's keep going. Exploded views. Paste that in here. Same thing. Compare. Okay, so on the left it says which is on the same sheet as another figure. On the right it says figure that is on the same sheet as another. Okay, so a little different, but pretty much the same. This one uses which, this is using that, and the formatting. Virtually the same. Let's clear that. Let's keep going. Partial views. Copy that in here. Copy that here. All right. Compare. Identical. Shocker. Clear all. Okay, these are the same. I'm not going to check that. I mean, get the idea. Ambiguous here, ambiguous here. All right. Let's do something a little more, I don't know, richer. Let's try something. It's got a lot more in it. All right, so sectional views. Let's copy this down to 45 degrees. Copy that out. So that on the design patent side, paste that. Oh, 45 degrees. All right, good. Copy the top section here. Copy that. Put that in here. Bam. Compare it. Okay, so here on the utility patent side, it says plane on which a sectional view is taken. Over here it says plane upon which a sectional view is taken. It says indicated on a view from which the section is cut by a broken line, and this says indicated by a broken line on a view from which the section is cut. Okay, so you get the idea. The ends of the broken line, the ends of the broken line, etc. Okay, it's virtually the same. Why am I not surprised? All right, clear all. And then it said we'll go from the cross section down to cross section is fine. Copy that out, paste that in. Same here, cross section, cross section. Compare that. Okay, minor differences. Semicolon on the utility patent side, a comma on the design patent side. For the materials, it says materials that is illustrated in the cross section, and here it says materials illustrated in the cross section. The same thing. Clear all. All right, so I think I've pretty much driven that point home. You get the idea. They are the same. All right, so let's talk about those views again. All right, so, okay, plan, elevation, section, perspective. Where's the regular language? From the side. And the reason why they're using this kind of language, because it has to be detailed because there's a lot of views in a three-dimensional space. There's a lot. They call it multi-view projection. Right? This is how you characterize an angle in language, in text. Right? So how do you write that up? It's going to sound extremely complicated. So the language you find for a design patent or utility patent are pretty much going to sound just as complicated. Right? They have to explain it in such a way that makes sense. And they pull that from multi-view projection. If you scroll down, you'll get those angles defined. A plan angle. A plan is a view of a three-dimensional object seen from vertically above or below sometimes. It may be drawn in the position of a horizontal plane passing through above or below the object. So basically, it's looking down, like you're looking at a plan. Right? It's a flat surface. So that's what a plan view is. Elevation. An elevation is a view of a three-dimensional object from the position of a vertical plane beside an object. In other words, an elevation is as a side view, as viewed from the front, back, left, or right. So it's looking at the side depending on your vantage point. So that's an elevation. Sectional views, self-explanatory. We don't have to get into that. But they give you some items that show you what those look like. All right, let's cutaway of a Porsche. 2D cross-section view of a compression seal. Cross-section of a jet engine. All right, and there's a lot of this in your patents. Whether you're doing utility or design, you may feel the need or maybe required that you actually show that. There's something else I want to take note of. Notice the lines. This is material hatching. So these lines pretty much indicate that we're talking about steel, all right, or some kind of metallic material. So material hatching is pretty common stuff in most of your CAD design software, but I'll cover that in another video. Let's keep going. All right, let's take it back to the actual angles. So again, a plan view is looking down like you're looking at a plan. An elevation view is a side view, essentially, whether that's the front or the left, the right, or the back. Essentially a side view of your product or the object that you've modeled. Now let's take a look at perspective view and isometric view. Now why are those different? First of all, the language defines a perspective view as being sort of a 45-degree or three-quarter angle, right? Now what's the exact difference? The perspective view is how we look at an item as we're human, right? How our brain processes an image. It's the images that are closer to us appear larger than the images that are further away. So you notice in a perspective view that in this Lego piece, the first notch is a lot bigger than the second notch, right? Very common stuff. I don't need to explain that. You get the idea. An isometric view does not share those attributes. So an isometric view is going to make sure that those notches are exactly the same, regardless if they're closer to us or not. So an isometric view will maintain the dimensions of that design, whether it's nearby or far away, whether it's at an angle or not. In fact, you could take a lot of your designs, make them isometric, and it's going to look a little funny because it's not the natural way we view objects. The way we view depth does not exist in an isometric view. And the more you mess with isometric views, the more you realize how slightly askew it's going to look, because it's not an natural angle. It's an angle to represent dimensions. Okay, a perspective view does not represent true dimensions because we perceive that view as depth. Closer items are larger, further items are smaller. So I think you get the idea there. So that's what they mean when they're talking about plan, elevation, isometric, and perspective. There's also sectional views. I'm covering that in another video. There's your classic perspective view. All right, so that's what it means when you're reading that language and you're preparing your patent application. Hope you find it helpful. Don't forget to rate, comment, and subscribe.